Hello everyone, today we'll solve the short prime path problem. Consider a set of 4-digit prime number. Two prime numbers are neighbors if they differ by exactly one digit. Given two prime numbers, we want to find the shortest path between these two prime numbers. The problem can be solved with the breadth first search method, BFS method. The key idea of BFS method is to explore all nodes at the same level before moving down to the next level. With this BFS method, it is very straightforward to determine the distance away from a node in a graph with an equidistant neighborhood. For example, we have a graph like this. A, B, C, D, E. 5 locations. The distance between the two neighboring locations is 1 kilometer. We want to find the shortest distance from A to E. In BFS method, we push A into a DAG first. And assign its distance with 0, since A is the starting point. Then we pop A out to explore its neighboring location. A has B and C neighbors, and we never visited them before, so we push B and C into the DAG. And update their distance by adding 1 kilometer to the distance value at their closest up-level neighbor, which is location A. So the distance is 1, because 0 plus 1 is 1. 1 for B and 1 for C. Now we move to the next level to explore the neighborhood at the next level. So we pop B out and explore B's neighborhood. B has neighbors of A and D. A is visited before. No action on A. D is a new location, so we push D into the DAG. And update the distance with 2 is 1 plus 1. Now we look at C. So we pop C out. C has neighbor of A and E. A is visited before, so we push E into the DAG. And update its distance with 2 kilometers, because 1 plus 1 is 2. Since E is our destination, so we are done with our search and return the shortest distance from A to E is 2 kilometers. Okay, let's see the code. In this code, this portion is a graph class. In the graph class, we are using dictionary to represent the graph structure. Each prime is a dictionary key, which is a vertex. The dictionary values, which are edges, are the primes which differ from the dictionary key by only 1 digit. This portion creates a prime list with the linear sieve method. For more information about the linear sieve method, you can check my previous video. The link is below. This portion is the main program. We first create the prime list. Then we use Python zip and sum function to create a graph where there is an edge between two vertices only if they differ by a single digit. Last, we use Python DAG module to implement Brave first search method. In BFS method, we use while loop to explore all vertices. This portion is to explore all neighbors for the current vertex before moving to the next vertex. If the neighbor is not visited before, we push it into the DAG and update its distance. When the neighbor is our destination, we return the result. That's all for today. See you next episode.